Hello and welcome everyone. Today's lecture is based on the building drawing, and specifically we will see how to draw the plan of any building. So any typical floor plan we will see. So before getting into the lecture, I would like to request you to take some notes and obviously prepared with your calculators and pens and any other necessary things so that you can take part in our quizzes. There will be some quick quizzes within the lectures where you'll have to take part, and based on your participation, your performance, we will be evaluating you how you perform in this class. Okay. The first one, to give the correct answer, you will have to give the answers on your chat box in the Google Meet option. So let's start the class. So first of all, I would like to show some remarkable components of superstructure. I think by this time you should have known the differences between the superstructure and substructure, which is superstructure and which one is substructure we call. So some remarkable components will be planes, walls and columns, beams, arches, roofs and slabs, lintels, sunshades, parapets, steps and stairs. Some components you know by this time, I think, and there are some other components as well. We will combinedly try to discuss all those components one by one. So first, to start with the plinth. So as you can see, this is the plinth here, plinth shown there. This is the plinth. So that is elevated from the ground level. If this is ground level, this is the plinth, using some steps so to provide a support from where the original structure or building starting from. So the reason behind to give the plinth to start the structure from a specific elevation from the ground level is to protect the building from any kind of flood, inundation, whatever you say. If there are rainfalls there might be water clogging into the road, and there is possibilities to and the water to be entered into the building, to protect building from that. And based on the survey, the flood level, the guidelines, everything, we generally define this plinth level for this building. However, then we start the floors over this plinth. So this is the plinth level, as you can see. So we will be we'll be converting here again within the plinth. We'll have to define ramp later on, referring to this plinth. So let's go to the next structure, that is arches. Arches, as you can see, we all know this well-known curvature shaped masonry structure. You see, so this is called arches. This is well-known, renowned structure we can see everywhere, even now. So the next thing, the slab, beam and column. This is known as the frame structure. We commonly use the term frame structure for defining this kind of structure, where there is a slab, there is a beam, there is a column, there are some columns, some beams to support the slab. This structure, as you can see from there, so where the slab is taking the gravity load and distributing this over beam, and after that the column, and the column will be transferring this to the footing, and after that to the soil. So these components, the beams, are the horizontal components. The slab is the area used where we use the floor area, that is called the slab, and the column are the vertical components, the vertical members of any structure. We know this is column. So there is another component we know as lintel. So lintel will be this particular component of a building. As you know, that block or bricks, it cannot support its own weight, So if this space is hollowed, nothing is there. If we don't give any structure there, any lintel there, there is possibility of this bricks or blocks, whatever you say, of falling down here. So protect it from falling, so we use this component lintels, and a lintel is actually RCC component of a building, reinforced cement concrete building, where there are some reinforcement within this RCC component. Next, this is the seal. Over window we can see some spaces over there. This is called the seal. The difference between seal and lintel, the lintel is placed over the window or door, whatever, every opening, whether it is window or door, we can see lintel over there, and the seal is the component below this window, just below. So we don't usually use the window in direct contact with the wall, and rather we use seals over there. However, now there is a quiz for you. So the first one will be given bonus mark. So you can pause down the video and move further. Superstructure is the portion of the building that lies above the plinth level, below the plinth level, above the ground level, or below the ground level. First one to answer will be given bonus mark. So I think by this time you have given the correct answer. The correct answer would be the above the ground level. So we define the superstructure, the structure which lies above the ground level, as we can see from the previous slide where we have mentioned that this portion, as you can see, over the ground level, the total structure, we will know this structure is superstructure, and the below this is substructure. However, so you'll have to be prepared. There are more quizzes after this. Okay, there are some guidelines, thumb rule guidelines, as you can see. In hot and humid regions, window area should be 15 to 20% of the total floor area. Another thumb rule we can use: every 30 cubic meter of inside volume there should be 1 square meter window opening. So if we say in case of hot and humid region, then first we'll have to take the total floor area. Total floor area means the floor area we can see from the plan view, and the window area we can see from the elevation or section view. That means so this should be the 15 to 20% if the region is hot and humid. And in general, in case of any normal place, we use 1 square meter window opening for every 30 meter cube of free spaces. So now there will be a quiz for you again. Quick quiz. In a humid region, if there is a confined room of 20 feet by 15 feet, according to the thumb rule, which represents the required area of window, as we have discussed? So I think by this time you have evaluated this. This will be 19 square feet, the correct answer. As it is humid region, you will have to find out the range between 15 to 20%. After calculating the area, then you will get the window size. So next we'll see the ramp. In many cases, commonly we see in different apartment this kind of structures. Why this kind of structure? This structure is called ramp. So to give the provision for the vehicles to enter into the building, we give this kind of ramp structures, or there are some guidelines in our Dhaka Metropolitan Building Construction Rule as well for universal accessibility. There may be vehicle ramps, or there may be other types of ramps where any wheelchair user can enter into the building. So give universal accessibility support, we need ramps. There are provisions, although we don't follow these rules, abide by these rules most of the times in Bangladesh. So however, so this is the ramps. The main reason behind this ramp is if we want to see the plinth level again, the plinth level, if we can provide the steps for the human beings to enter into the building. But what about the vehicles? To give provision to the vehicles to enter into the building, that we need some continuous smooth slope over there so that the vehicle could enter into the building. That's why we need to give ramps. So there are terrace. I think all these components by this time you must have known. However, this is terrace. We generally see the extended portion, the outside portion. It might be in the roof, or it may be in the ground floor as well. Beyond the structure, beyond the building, we can see this kind of terraces, or in the roof as well. And floors, we define every story of a building as floor. As you know, the ground floor is prepared by filling brick pads, wet stones, gravel, and well compacted with not less than 100 millimeter sand layer on its top. So if we get back again to the very first plinth figure, so we'll give some sand filling over there. There will be a floor concrete, and then after that we'll give a floor finish over there, and there we might use damp proof course. So all these things, this sand filling. So why would we use this? To prevent the water. There may be capillary action. You know, capillary action brings the water from the below the ground to the top of the plinth level. So prevent this water to penetrate into the original superstructure. We use this damp proof course. We can say damp proof course, or sand layer. Sand, as we know that the sand layer, sand is kind of soil where the porosity is not like the clay layer, so that's why there is less possibility for sand layer to be involved in capillary action and hamper the building. So we also use damp proof course. By name we can we can know that damp proof course will prevent the water from entering into the structure. And after that we will give floor finishes done as per requirement. This is all about the ground floor. In ground floor we do not use any kind of reinforcement in the slab. Rather we use this as we have mentioned, and all other floors are RCC finished. That means we have to construct all other floors over ground floor. If it is first floor, second floor, typical all floors. So a lean concrete of 1:4:8. This is a ratio. We generally use different types of ratio of concrete, cement, coarse aggregate, and fine aggregate. This ratio, fine aggregate, coarse aggregate ratio, that is mentioned in this way. However, there is a typical stair, we can say step. So we can divide its component into three major parts. This is called the rise. As you can see, rise. There it is rise. This portion is called run, and this portion will be called tread. Tread will be including this extended portion sometimes we see, and the run is the only portion exclusive portion from this. So where we'll have to land, this portion is called the run, and including this extended portion we call the tread, and the rise is the elevation cover is from each step, that is called the rise. In general, you know that the rise, every rise is actually 6-inch, and 10-inch run commonly we use, or tread width is 10. Next, the foyer. Foyer, that will be can be defined as the entrance hall. When you first enter into any apartment, any building, you will see a large opening, large hall there. This portion is called the foyer. The mezzanine, you can see sometimes there are in between stories which is not cover the total floor area all the time. Generally a portion of area is covered, not the total floor area, as you can see in this floor, and the above floor may be there, but this is not covering the total floor, rather some portion of the floor in between floor, so that will be called the mezzanine. We see air ducts over there. Air ducts, as you can all see, there might be a central air conditioning system. For that we use air ducts, or there's maybe vent pipes as well. Vent pipes are vent pipes, you can see these pipes, this is very well known pipes. So because of aesthetical point of view, we generally use vent pipes within the building nowadays, not outside the building, so it will look like something is not aesthetical if we see from the outside. So these vent pipes will be within the building nowadays. However, the next portion is the parapet wall. As you can see, this is an exclusive type of parapet wall we can see in the buildings, although most commonly we see the brick walls as parapet walls. Parapet walls is used in the roof, where it is mainly the uses of this parapet wall is to protect people from falling down, overturned from the roof. So this protection is provided by the parapet wall. So it may be of fiberglass steel railing, or it may be made of bricks walls, etc., whatever. However, so generally there are standard door size we can use: main entry door, bedroom door, kitchen room door, toilet room, storeroom door. The dimension are given, the width is given first and height is given after that. This is the general provision to show any dimension, mention any dimensions. And from the dimensions, as you can easily see, the main entry door, that is 3 feet 6 inch commonly used. The bedroom door will be less than that width, kitchen will be less than that. This indicates that whatever you use in your building, appliances or anything you make enter into the building, everything will have to make sure that main entry door can give access to those things. So that's why it should be large enough. And then bedroom, then kitchen room will have this width based on our requirements, the width of different appliances or anything we use in our building. Okay, so in toilet only 2 feet 6 inch, that means only people, you will not use any table or chairs within the toilet or storeroom. That's why we don't need very large width for the washroom or storeroom door. So from from our common sense we can easily understand this thing. However, the standard window size are given there. Although we use exceptional, some dimensions are also used. So these are the very standard window size we use. Bedroom window will be 5 feet into 4 feet 6 inch. One thing, if you have noticed that the door, all doors have been taken as 7 feet height. This is the standard height of any door we use, and the typical story height is 10 feet we use in general. So if a typical story height, floor height is 10 feet, and the door height will be 7 feet from the bottom of the floor. And window size, as you can see, window size, the width is varying, also the height is varying over there. So in bedroom window, in generally commonly we see 5 feet width and 4 feet 6 inch in height. And most of the time we know the window also starts from 7 feet above, and the only differences is the height from 7 feet. How what will be the height that will be varying the window size, nothing else. We will be clarifying this thing in the next slide, inshallah. So in kitchen you see 4 feet window, toilet 1 feet 1.5 square window is something opening we see. Drawing and dining room we use this large or bedroom type windows, and full height veranda or sliding window we also use this dimension as well. So sliding window, or we can say sliding glass door as well sometimes. So window, if we give example of window, this is a typical window. We can say always the window will be always going to from bottom story, it will be 7 feet height above. So based on the dimension, the width and window height will vary. Like if this is a bedroom window, so this might be a kitchen window if this is 4 feet height. Previously bedroom is 4 feet height and width might be 5 feet. For a toilet it might be a square window, 1.5 feet by 1.5 feet, like this. But whatever the dimension is, most commonly we start from the above 7 feet, the window reference line, and then we can take different kind of windows based on our requirement. So this is the basic of window we generally use. So if a window is of height 4.6 feet, for that means that there will be 2.5 feet place filled here with wall, and above that the window starts up to 7 feet. So if we tell about wall, this wall will clarify you the dimensions. Generally this is a typical brick. We use mortar to place the brick over there, and after that we'll placing mortar here and there. Generally this is called the width, this one is called the length, and this one is called the thickness of the brick. So thickness, generally typical brick thickness is 5 inch after finishing. So we have to remember that we always speak about this thickness, the length, width when we are using mortar, the finished brick. There will be mortar in this side and that side as well, top, above and below we see the mortar as well. So the combined finished brick that will be have thickness of 5 inch every time. Next, we use different types of building drawings. So namely drawing types may be architectural drawings, structural drawings, electrical drawings, plumbing drawings, finishing drawings, etc. So this kind of drawings we generally use. So in architectural drawing we generally use site plan, working plan, elevation drawings and section drawings. So to give example, this is the site plan, total site plan we use in architectural drawing. then working plan or floor plan, which we'll be watching today. This is a sort of example of floor plan. Then elevation drawing, so how we see any building from outside in an elevation view. And also the section of drawing, so if we take section along different points, different sections through the building, so how it will look like, that is called a section drawing, section view, as we know. There are structural drawings. Structural drawings will contain the general note giving some idea about the material properties which have been used in the design. The excavation drawing, footing layout will be there, column layout, plinth or grid beam layout, reinforcement details will be given there, beam, lintel, beam layout, reinforcement details. The beam RCC we use in lintel we have shown. The typical slab layout or typical beam layout may be also included there. Typical slab layout, roof slab layout, in all these drawings will be included in the structural drawing of a building. So before getting into the drawing, we will have to know what are the scales used in drawings, and what are the differences between architects and engineers scale. So generally we use architect scale in case of floor plans of houses and average size structures, which we'll be watching today as well. The engineer scale is used for designing bridges, roads, water mains and topographical features, which is obviously very large structures, so we need to use for those things engineer scale. And metric scale is used when measurements and dimensions are in meters, centimeters or millimeters. Architect scale and engineer scale, obviously we use in this case inch or feet, and in metric scale we use meters, centimeters and millimeters. So there are commonly used architect scales, where we can see the original inch scale called 16th. There may be 33 inch equals to 1 foot is also called 1/4 scale, just because to clarify this thing, 3 inch equals to 1 foot means 3 inch equals to 12 inch exactly. So the ratio will be 3/12, and that is 1/4, also called 1/4 scale. 1/2 inch equals to 1/4, that is obviously half of 1/4, that is 1/8 scale. So hence we can see all other scales are mentioned here. 1/4 inch will be used for 1/4, so that 1/4 divided by 12, that will be 1/48 scale. So thereby we can define all these scales. These are the commonly used architect scale, typically conventional scales. So also if you have the rulers, the scales with you, the triangular scale we generally use, or cardboard scale, whatever you say, you should have seen these scales over there. So if we clarify the architect scale, there will be two scales, will be illustrating actually 4 scales. This is 3/30, 3/32 scale, and this is 1/8 scale. So this one 0, 4, all this scale are 3/32 scale. You can also see a 3/16 scale from starting from the opposite direction, 0 to 4, that is doubled, kind of doubled. So we cannot take the aspect ratio of this portion as it is broken there. We can take this ratio to compare with. So as you can see, this 3/32 scale, and difference between 3/32 and 1/8 scale will be 0.75. How we can say in 3 by 32 scale, if we use 3 by 4, that is 0.75, with 1 by 8, it will give you 3 by 32 scale. So 3 by 32 scale, that is 75% of 1 by 8 scale. 75% of 1 by 8 scale will denote 3 by 32 scale. So to clarify this thing, we can give example of this reference now, although you can see this has not been started from the same point, and not the 0 point lies in the same line, vertical line, but still we can take the approximate assumption to understand this thing. So let's assume this is started from 0 at the same time, and this line will be intersecting 24 and 32 of these two scales. So if we focus on 3 by 32 scale, the 32 3 by 32 scale gives 32 measurement, and if we take 0.75, that is 75% of this 32, that will be equals to 24, and which is this one. So that means the same distance, this is covering 32 feet, and this one is covering 24 feet. This is actually in feet, all these things are given in feet. There may be multiple divisors, more divisors than it is shown there on the scale. It might vary, however, but the actual points, this is 32, this is 24. The difference between these two is the same space, it will attach 32 feet, whereas this scale will accommodate only 24 feet within the same space. And again, how to quantify? If this is 0, this is 1, then 2, then 3, then 4. This one is 4. So each of these division denotes 1 feet, So again, for this case as well, 0, 1, 2. So how to take the dimension like 1 feet 3 inch, as it is given there, 1 feet 3 inch is given there. So let's move to the next slide to give a close view over this. So if this is the 0 line, you will assume divisions over there. We can divide it into 12 inch, although it will be very, very approximate. Without CAD drawing, we cannot exactly quantify this dimension. So if this is divided into 12, division 12 inch, then 25% of that will be 3 inch. So we can say this is 1, and the extended portion there over, that will be 25% approximately. From the figure you can say that will be 1 feet 3 inch. In case of this as well, this is 1 feet, and we can divide this into 12 portion, and 3 of that, or we can say if we divide 4 divisions and 1 of that division will denote 3 inch. So total this will be 1 feet 3 inch. That how we will have to quantify whenever you will be drawing in your drawing paper, if you don't get enough divisions over there to count. However, so that's how we'll have to proceed. Now there is a quick quiz for you. If a building P is drawn within a specific paper area using 1 by 16 scale, another building Q is drawn within a specific paper area using 1 by 16 scale, another building Q is drawn within the same paper area using 1 by 12 scale. Which building possesses greater area in actual dimension? Whether it will be P, Q, P and Q are the same or cannot be determined from the information given there. I think by this time you have got the answer. That will be P. P will be possess greater area in actual dimension, as we have discussed earlier. Now we'll see commonly used engineer scale. 6 types of scale we generally use. Engineer scale: 1 by 10 inch equals to 1 foot, that is 1 by 120 scale. 1 by 20 inch 1 foot, 1 to 40, that's how. 1 by 360, 480, 600, 720 scale we can obtain. And one thing you will see, we are using very large area, just because we have mentioned earlier that we use engineer scale for showing the bridge, roads, etc., not like the building, typical building, which is not so big in dimension. So in engineer scale, obviously we'll have to use 1 by 120, 1 by 240, so the scale will be very small to accommodate the very large dimensions. However, so what will be the differences between architect scale and engineer scale? Not as you can see, that is written over there, architect scale and engineer scale. From there you can identify there are some differences you should know, so that you can identify. So in architect scale, you will be seeing that there will be divisions that we have seen earlier, that engineer scale and architect scale, the scales, conventional scales we use, we have mentioned earlier: 1 by 4 scale, 3 by 32 scale, 1 by 8 scale. Those scales you can identify. And also in engineer scale you can identify by these things, 10. So just as we have seen there, 1 by 10 inch equals to 1 foot, 1 by 20 inch equals to 1 foot. That's how you can quantify the scale, identify different scales. And another thing, you can use you apply your common sense. There will be only one scale in architect scale which will have only one-sided dimensions. In all other cases you will see two-sided dimension, two-sided scales are there, divisions are there, from this side left to right and right to left. But in engineer scale we will see only one dimensional divisions in all sides, and that is rare in architect scale, just because as we have discussed earlier that engineer scale we can use 6. So in this triangular scale we will have six sides, in case top and bottom in each side, 3 sides, so 6 portions we can use 6 scale. And architect scales more than 6 scales, namely 11. So for that except only one portion, all other portions will contain 2 types of scales, as you can identify from visual inspection. So let's move to the next slide. If we see the provision of building plan, so we'll be getting into the building plan now. Before that, as you can see, this is taken from the Dhaka Metropolitan Building Construction Rule. Any mezzanine, any foundation floor below the ground level, or all typical floor plans must be 1:100 scale. You'll have to provide 1:100 scale drawings for those. So this is not as typically we have seen in our previous discussions. So there will be quiz for you based on this. Which type of scale is provided by Dhaka Metropolitan Building Construction Rules 2008? Whether it is architect scale, engineer scale, metric scale, or none of the above. I think by this time you have got the answer. This will be a metric scale we used. However, we shall stick to architect scale in our course. DMBCR used metric scale just because 1/100 scale is not used in engineer scale, neither engineers neither architect scale. That is used in metric scale. and we know the all drawings, all designs must be shown in millimeter or centimeter or meter in case in Bangladesh, whenever we're submitting any design. So that's why the provision has been modified based on those metric scales. However, so there are different symbols of doors and windows we generally use in our drawing. So as you can see, there are doors. We generally use this kind of doors, very typical used doors. There might be crossing doors as well, or sliding glass as well. Window, typically we use this kind of, or glider window might be there, and other less commonly used door and window types are also given there. So dimension general rules on drawing. So generally we use width multiplied by length. First width, after that length for plan view. So example, 15 feet into 20 feet bedroom. If we say 15 into 20 feet bedroom, that will be obviously area excluding wall thickness as uses TLR point of view. That is, when you a client will see this bedroom is 15 feet into 20 feet, that obviously means the available space, not including the thickness of wall or column or beam. Obviously not. The available space, free space, that will be called the as this dimension, 15 feet by 20 feet. However, this first portion will denote the 15 feet means width, and the length, that will be this one, length of the view. So again we'll use width into height for section and elevation view. So if there is a window over there and we are using dimension 5 feet into 4.5 feet, that will indicate that width of this window will be 5 feet and the height will be 4.5 feet. So, or as it is given there, 5 feet into 4 feet window, then it will denote 4 feet of height, 4 feet of height, whatever you say. Thickness of wall, if we say 5-inch brick wall thickness, as we have illustrated previously how we designate the walls. If this is a brick, from plan view we'll be watching this portion. This portion is called the thickness of the brick. Length and width we have discussed, height of the brick we have discussed earlier. So this thickness will be used by us, the 5-inch brick. The procedure for drawing floor plan will be, first we'll have to use proper drawing pencil at each time, as we have directed you to use HB, 2V, in which case we'll have to use which type of pencil we'll have a well concern about that thing. After that you will have to prepare the drawing sheet, border, drawing info, etc., and then you will have to determine the available drawing space considering the dimensions and other text as well. Then this available drawing space, how to define this space, I will be showing this after this slide, inshallah. We define north direction on the drawing sheet. Obviously you will have to give a north direction in the drawing sheet. Without this direction your drawing will be completely null and void. However, choosing appropriate drawing scale, you will have to then choose an appropriate drawing scale based on your available space, the space we have just obtained from there, and obviously you'll have to mention the scale on the drawing sheet, that which scale we are using in these drawings. Unless specified by the provision, as we have seen that 1:100 scale is defined for floor, then we'll have to obviously go for that scale. Anyhow we'll have to fit the drawing within our paper, our sheet. So then draw the center line or grid as per requirements, as you will be identifying the columns on the plan. So first of all, we'll be drawing the center lines and grids as per requirements, and referring to those grids and center lines, we'll be completing the total floor plan. Then complete the plan taking offsets from the center lines. So we'll be taking offsets from the center lines to redraw the complete the other structures, wall, rooms, different kitchen, toilets, everything. So we'll be completing based on these center lines and taking offsets from there. And after that, we'll be providing hatches, dimensions, text over the drawing. What is hatch? Hatch, for brick wall we use this kind of hatch. This is called hatch. So whenever you see this kind of hatch, you will see, you can say this is brick wall. So if you see the column, in case of column, RCC column, we use this RCC denotation, this triangular aggregate thing, and dot 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 dot, this noise. So this is indicating RCC component of a building. So thereby we use different types of hatches to define different types of components, and make sure we will be only using these hatches if those components are cut by the plane, after which we see the plan view. And finally, we'll have to give the dimensions as mentioned, and text over the drawing, whatever written and necessary things. So now we'll be watching how to determine the available space. One typical video will try to illustrate this thing. So say this is, first of all, this is your drawing paper. After that, this is A3 paper actually, so 16.5 inch by 11.7 inch this will be. Then we'll have to create border first. As you know, in the drawing sheet, a border you will have to draw there throughout the drawing sheet. Then what we'll do, then we'll divide this portion again like this one, then divide these portions like this, where we'll write down name, ID, submitted to info, blah blah, whatever you know by this time. Then our task is to show the north direction like this one, and then we'll have to define another space. As you know, there we show the title of the drawing, as you are mentioned to write down. So it will be the title, say write down capital block letter, capital letters, block letters. We will write this as title, civil engineering drawing building, for example. Okay, then we'll get the available space where we can draw the building. Where is the available space? Say this portion is our available space where we can draw the building. So we have kept some spaces outside of this just because to write the drawing floor plan, dimensions, etc. So this greenish portion, you can see, this will be called the available drawing space, and we have kept these spaces consider for dimensions or text, something we'll have to write down after that. So this will be our available drawing space. Within this we'll have to fit our structure. So let's say the structure will be like this one, building floor plan. So we'll have to anyhow fit this within this space. So doesn't mean it doesn't matter whether we have this space left over after drawing, but we'll have to fit it with the governing dimension. We cannot increase this further just because it will cross this height. So however, this this indigo colored portion component is our building, that is our floor plan that will be attached here, and below this then we'll be writing floor plan, the designation, the title of this particular drawing. Then that's how we will move. Then we'll give dimensions and all other things. So that this is your page setup you will have to follow. So let's move to the next slide. Now there will be a quiz for you. If you have an available drawing space on your drawing sheet is 8.5 inch multiplied by 5.5 inch, and a building plan will have to be drawn which have length of 43 feet and width of 35 feet, which available scale will be the most appropriate to use. Your hints for you is to determine the required scale, then choose the very next available architect scale, the conventional scale we have just mentioned. So I think by this time you have got the answer. This will be 1/96 scale, just because to calculate width, if it is fitted, the available width was 8.5 inch, we'll have to fit 35 feet over there, so it will give 0.02024, and to accommodate the length we need 5.5 divided by 43 multiplied by 12, that will give 0.01066, and this will govern to very next scale to this will be 0.01042, that is 1/96 scale. So we'll have to use this scale, available scale, for our drawing. So this is the tough procedure for you, but there is a simply easy procedure for determining scale, which you will have to use nothing for calculation. Just put your different scales. If you have cardboard scales or if you have triangular scale, just rotate your scales and place it over your available space to see if you need the longest dimension 46 to accommodate within the height. So you will try to see in which scale the 46 dimension feet accommodates within the drawing available space. Once you get the appropriate scale, then start drawing using that scale. That is all. So there are something we need to talk about additionally, that is the door position. About if we see the plan view of this door, you will see that this is the opening direction. As you can see from this frame, this is actually the view of frame, plan view of frame. And if you see there, this is the opening direction. There will be a frame like this. There will be a frame to accommodate this door whenever closed. So this group portion, you can see there a depression over there. Okay, so whenever this will be closed, this will be affixed to this frame after that. So the opening side will always contain the door. You cannot start the door from middle portion or this portion and open it over this side. If you start from this portion, the door must be open in opposite direction. So that's how you'll have to draw the door. And about this thickness, what about this thickness? Generally different thickness of doors are used, so we recommend to use 1.5 inch. It might vary from different context to context, however. So to talk about window position, the window position actually varies. If you see this window position, this is very much placed over the exterior side of the wall, and this is almost in the middle portion of the wall. And if you see this portion, you see sometimes we use grill over the window, and in this case we have used the frame of window in very interior space of the wall, and then we have provided exterior grill outside of that wall. So again you can see this kind of windows as well, so where there might be grill, shuttering, everything there, but this frame of window has been placed outside of the wall as well. So very very confusing thing in window. Also you can see this kind of thing as well, so where a window frame is there and a grill has been placed outside of that. So typically we see this kind of window. We can consider for our drawing this course we'll be following this. So we'll have to place a grill in the interior side, and on the outside edge we'll be keeping some spaces over there, and then place the frame of the window over there. So if we see this figure, this plan view, this window has been placed in the middle, at the middle of the space, middle of the wall, but we recommend to give it outside, exterior side, keeping some space, say 0.5 inch. If the wall is 5 inch, you can keep 0.5 inch space, then start these two parallel lines. These parallel lines may be 2 inch you can use. So all these things will obviously vary, but as we know that we generally use gliding window this time nowadays. So gliding windows is generally shown as like this. There will be frame, total frame shown there, and this portion one gliding window and another here within the frame. It can move throughout this this predefined frame space, as you can see. So sliding glass door, also if we see this in this drawing, it is also shown like this, as usual, as we have seen for the gliding window as well, the similar pattern. So if you'll have to enter into the veranda, you will have to slide this door and enter here. So the similar kind of door we'll be using in case of veranda, in case of sliding glass door. So very rare case nowadays we use doors opening like this in case of veranda nowadays. So if there are sliding doors, we'll be obviously giving as it is shown there. So not this kind, however. So now we'll see how to draw our building floor, which we'll have to draw eventually. All students will have to draw eventually. We'll see one sort of example. So that is our typical story floor plan. That will be our assignment. So if we want to give directions, so this is the total floor. So first of all we need to draw what? There is no direction given over there, so we'll have to give a north direction. Say this will be the north direction for you. So after that we'll have to quantify the width and also we'll have to quantify the length as well. So this is dimension, as you can see from there, that is dimension, dimension shown. So that is 33 feet 7 inch, and if we focus on this will be 42 feet 6 inch in length. So from this dimension we can easily first of all define the suitable appropriate scale for our drawing, then we'll be starting our drawing. So how to start? So we'll have to draw center lines, as we have mentioned. After you have come to the available drawing space, we'll draw a center line. So this is columns, as you can see. This is column, all these things are components column shown in the red components, these are columns as mentioned. So we will be drawing the center lines through the center line of the columns. So we'll be drawing center line through the center line of column. So let's denote this center line as different lines. Say we will be using yellow lines to draw center line of the columns. So we will show how to draw, how to define, how to take dimension of this column center lines. First of all, see how to draw. These will be all the center lines. You can see this is the center line of this column. So after that also this column will have a center line. So yellow lines are indicating the center line of columns. So you can see there is another column. We'll have to draw another center line over there. We'll come to this point later on. Let's complete, make this forward. First complete the center lines. So this one is the remaining center line. We'll have to draw another center line over there. So another center line will be drawn. So make sure, although we have used yellow lines, center lines, how it is drawn. Center line, the feature of center line, it is not a continuous line, you know. So how to show center line, that type of line you will have to draw. However, so also you can use some construction lines for your convenience. However, if all the center lines have been drawn, now we come to the point how to start this drawing. Just because as we have started the center lines, we see we don't know the positions. So how to draw these lines? So it is predefined line. As we know, these lines are already there, are the columns, all the columns we know. But previously, when you'll have blank paper, you don't know where the actual position of the center line is. So how to start? So let's take an arbitrary line which will be eventually the this center line. So first of all, you will take a vertical line like this. This will be called the first center line, first vertical center line, and obviously you need to count all the dimension, quantify all the dimensions here, so that it will help you to draw those lines. So this will be the first center line, and from this first center line we will be drawing the next line. So this is 5-inch wall, as you know. This is 5-inch wall. So if you see the column dimensions, typically we use say 12-inch by 15-inch. It will be given obviously. So in this case, assume 12 into 15-inch. Okay, so architectural drawing doesn't give, most of the time they don't give as the actual dimension. It will be evaluated after the engineering, civil engineering analysis, which will be taught in your maybe third year, or at the end of third year you will learn how to design those columns, beams. So then after analysis we will find the column dimension. Previously the architectural drawing only gives just columns wherever needed. So we know if it is the column is 12-inch, then this will be 6-inch, the half. If we use center line, the first half 6-inch, then the second half is also 6-inch. And also this column, although it has not been crossed, it hasn't crossed at the center, we can say this is 6-inch as well. So 6-inch, 6-inch. So width is 12 feet 3 inch. As we know, this width is the available free space. exclusively this free space, excluding the wall thicknesses. So if you want to take the actual dimension, what we'll do, this free space is 12 feet 3 inch. So to get from this yellow line to that yellow central line, you need to add this portion, that is 6 inch, and then this is 13 feet 3 inch, and then that will be again our drawing line after adding 6 inch. To clarify this thing again, what we can use, that is this portion. You can see this distance is not crossing the 5 inch wall, as it is 6 inch from there. So this yellow line is 1 inch from the 5 inch wall. So 1 inch you will have to subtract from 12 feet 3 inch, not as it is shown there 13 feet 3 inch. Forget about this thing, just focus on this, that this line lies 12 feet 3 inch minus 1 inch, that is this line to that portion, that yellow line. We'll have to see, if we deduct 1 inch from 12 feet 3 inch, it will get this one, and we have finished it in this wall. So again we have to deduct 1 inch again, so you will be getting 12 feet 1 inch. So distance from this central line to this central line will be 12 feet 1 inch. Okay, then again from this line, this width and height has been shown in wrong convention. Stair first width will have to be shown, although in Bangladesh in most of the cases we cannot expect this to be correct. This is 13 feet 4 inch should be given afterwards. So 13 feet 4 inch will be the length, not the width here. So however, this one will be our width, 7 feet 6 inch. So 7 feet 6 inch will be taking from this line, will be adding 6 inch to get this wall point, this line. Then so we'll be using this 7 feet 6 inch plus 6 inch plus again plus 6 inch to get to the next center line, this 6 inch to the next center line. Okay, so we have another center line in between these two. So we have another center line in between these two, so we'll see how to take this line as well, we'll see afterwards. However, similarly, for this bed space you can identify this line as well to calculate. Take this dimension, subtract this 1 and 1, then you will get the another dimension. Then we'll come to the very bottom center line, as you can see, very bottom line. So this line, how to quantify this line? So as you can see from the top, this is 42.5 feet, that is 42 feet 6 inch. If we come from this column center line, we'll have to subtract 6 inch, this point, this portion 6 inch, and in case of bottom we'll have to subtract 6 inch from there. So 4 feet, sorry, this will be 7.5 inch, as we have mentioned that column are 12 inch into 15 inch in dimension, so 7.5 inch. Also there will be 7. No 6 inch, that will be actually 7.5 inch. So that will be actually 7.5 inch. So 42.6 minus 7 inch minus 7 inch will give you the actual spacing between top center line and this bottom center line. So that's how you can draw this line. And similarly these lines have already been shown. So how to this line, remember this line you already have this line, so how to get to the this line, next line? So just use 4 feet width and use wall thickness. As you know, this wall thickness is 5 inch and it is going through the center of the wall, so we'll be taking half of the 5 inch wall, that is 2.5, and again for this line we'll be adding 2.5 inch, the half of the wall thickness. So 4 feet plus 2.5 inch plus 2.5 inch will give you the next center line. That's how you will draw the next center line. Okay, this line is already drawn, also the last line has been drawn. Now we'll have to draw these lines. We'll show how to draw this line now. So how to draw this line? So take dimensions from there. This is the center line, so there we know the free space will be 5 inch 7.5 minus 5 inch, that is 2.5 inch. So we'll have to deduct 2.5 inch from 11 feet. So obviously we'll be deducting 2.5 inch. Then we'll have to add this 5 inch wall. Then we'll have to add this height, that is 6 feet, not 6.6, that will be 6 feet. Then again this 5 inch wall we know. Then after that this is toilet, but we'll not be taking this one. To get this yellow line, this center line, we need to add 2.5 inch with that, so that just because this is 15 inch, half of that will be 7.5 inch, and if we deduct 5 inch from that we'll get 2.5 inch. So adding 2.5 inch more with this 5 inch we'll get this line, this yellow line. So that's how you will get this line, and not that line, obviously this line. Okay, this line we have already found. So now how to get the next line? So we will be going further, adding 4 feet further, minus 2.5 inch, and again adding the toilet 4 feet, and again adding 5 inch. And then what is this dimension? We don't know this dimension, so we cannot draw this line using this information. You see, throughout this portion you cannot identify what is this portion. So to get that line, obviously we'll have to count from the top portion. So let's come from the top portion. So as you can see, that is 13 feet 4 inch, and you see this height is 11 feet. So if it is 11 feet and this is 13 feet 4 inch, this 11 feet denotes this portion, and this 13 feet obviously don't designate only this portion, rather it is designating up to this portion. So this 13.4 feet we can get up to there, and after that we have a door of 3 feet 3.75 inch. So using that dimension we can get to this line easily. How we can get to this line? If we add 13 feet 4 inch with 3 feet 3.75, and then as we know this is 12 inch, so half of that will be 6 inch. Adding that will give you this line. Using this you can easily get this yellow line. So 13 feet from the free space, as we know, so you'll have to deduct the the remaining portion, that will be 2.5 inch, then add 13 feet 4 inch, and then add 3 feet 3.75, and then 6 inch to get this line. So that's how you will be drawing these grids. And then the lift. This lift 5 feet height is known, so adding 5 feet with this top thickness 6 inch and this bottom thickness 6 inch, you can easily draw the next line. So if we start from there, this is from there we know 6 inch first, then we can add 5 feet, and then we'll be again adding 6 inch to get this line. So by this time we see we can draw all the lines, all the central lines will be drawn accordingly. Now we can start the drawing. Once you have drawn all the central lines, after that you can start your civil engineering drawing floor plan of the building. So how to draw? You will have to take the offsets from all this. Once you know this crossing point, intersecting point, you can draw the a offset line from this point. As you know, from 6 inch offset from this intersection, if you draw a line, that will be the outside brick line. And if you take 1 inch offset from this intersecting point and take a line, that will be the inner wall side line you will get. And obviously you can draw the column as well from the center point if you want to take. As you know, the column dimension half and half, 7.5 and 6 offset will give you this corner, and then you can draw the column. So all these things can be drawn accordingly. You can easily draw this thing, I hope. So that is how you'll have to proceed. There is something we need to talk about, the stair. So what does it indicate? This is upside, this is downside. What does it indicate? Whenever we are crossing, we are taking a plan. Say this is a plan, building plan. If we take the ground floor plan, this is cut on the half of the height. That's why the upper stairs have been cut down, so we cannot show the upper stairs, so we can only see these stairs. So that's how we'll be using these stairs to get up. So in the ground floor only, we'll see this type of plan. That is, we have only the portion using which we can go up to this level. But in this portion we will not see anything in the ground floor. But what will happen in the typical floor, in the next floor you will see two types of stairs. One stair, obviously if we cut in this cutting plane, this stair obviously you will see, which will give you a landing over there. But another yellow types of stair you will see, which is coming from the bottom side that is giving you this floor. So yellow side, this will be the downstairs, and this portion will be the upstairs, and there will be another upstairs there, but as we have cutted it into the half of the height, we cannot see the upstairs. This downstairs we will see, and this one we will see. So that is mentioned there as up and down. As you can see, this is the down. So this one is actually not this is not the portion of this floor. It has come from the bottom story, and this upside is actually the portion of this floor, and another upside stair direction is going there. But as we have cutted it into the 5 feet wall, we cannot go see those things, and rather we are seeing the bottom stair of the bottom story. I think you have understood how to draw this thing. So here you will see there will be correction, as there are veranda. It will be a sliding glass door over there, not as it has mentioned there. So please modify this while drawing. Also in case of this, there will be a sliding door over there as well. Also in case of there wherever there are verandas, you will have to provide sliding doors. So I think now you can draw. So that will be your assignment for the next class. So submit these assignments, and if you feel any complexities, obviously don't feel any hesitation to contact with us anyway. So that is our lecture for today. Thank you.